Let's start from question number 63. Question is that square ABCD lies in the third quadrant of xy plane such that vertex A is at -3, -1 and diagonal DB produced is equally inclined to both the axes. The diagonals AC and BD meet at P -2, 2. Find slope of BD and equation of AC. So to understand this question better, we can draw a rough figure like this, and then we can see that point A is -3, -1 in the third quadrant, and the intersection of the diagonals is point P, which is -2, 2. So they're asking us two things. One is what is the slope of diagonal BD and what is equation of AC. So if I look at slope of BD, now BD is a diagonal, AC is a diagonal of square ABCD. So I know that the diagonals of a square are perpendicular to each other and they also bisect each other. So I will use that information, and diagonal AC is intersecting diagonal BD at point P. So P is the midpoint of the line segment AC as well as BD. So therefore, if I am interested in finding the slope of AC will be same as slope of AP, because AP is part of the same line segment AC. I know coordinates of A and P, using which I can find slope of AP same as AC, which is difference of y coordinates -2 minus of -1 divided by difference of x coordinates -2 minus of -3. So if I calculate that, slope of AC comes up to be -1. Now since I said that diagonals of a square are perpendicular to each other and they bisect, slope of BD, let's say if it is M2, then product of the slopes of AC and BD will be equal to -1. This is the condition for perpendicular lines, so which is product of slopes is -1, and hence the slope of BD has to be 1. So that is the first part answer, that slope of BD is 1. Then to find equation of AC, I already know that slope of AC is -1, and let's say that AC passes through point A having coordinates -3, -1. Then I know the slope of AC, I know one point on AC. So I can use point slope form, which is y minus y1 equal to m into x minus x1. So x1, y1 value is -3 and -1. Slope m value is -1. So if I do the substitutions and I rearrange it, I get the equation x plus y plus 4 equal to 0. Ideally, it's better to write the equation in this format where all the terms are on one side and x coefficient is a positive number. So here it is 1x, x plus y plus 4 equal to 0. You can also write x plus y equal to -4. It's the same thing. Let's move ahead to question number 64. So 64 is about ABCD is a rectangle where BC is twice of AB, and it's given that triangle ACQ is similar to triangle BAP. We need to find the ratio of area of BAP is to area of ACQ. So here they're asking ratio of areas of two triangles which are similar. We know that ratio of areas of similar triangles are equal to the square of their ratio of corresponding sides. So I just need to understand what is the ratio of the corresponding sides for the pair of similar triangles, and then we can get the answer. So they have given some fact that ABCD is a rectangle. So let's say that angle B is 90 degree and BC is twice of AB. So if AB was x, then BC length is 2x. And then I can find the diagonal length AC by using Pythagoras theorem. So if I use Pythagoras theorem, I can find that AC square is 5x square. If I start with AB as x, BC is 2x, then AC square is 5x square. Anyway, AC, if you wanted to write, it is root 5x. Okay, now given that ACQ is similar to BAP, if I want to write the ratio of the similar triangles BAP and ACQ, I can look at BA and AC. These are corresponding sides. So the ratio of area will be BA square by AC square. Now BA square, BA or AB is x. So it is x square. AC square is 5x square. X square by 5x square is 1 by 5, or the ratio 1:5. So that is the required ratio of areas in this question. Then moving ahead to question number 65. Question number 65. In this given figure, triangle ABC is there, and D is a point on BC such that BD length is given, DC length is x, and angle BAD is equal to angle C. So this angle BAD is equal to angle C, that is given. AB measure is given. Then we need to prove that triangle ABD is similar to triangle CBA, and then find the value of x. So if I'm looking at this question, first I can say that to prove that two triangles are similar, first is angle B is common to both the triangles ABD and CBA. Angle B is common, and another information which is given is angle BAD is equal to angle C. So BAD is equal to angle C, which I can write it as ACB. So out of the two triangles, I have one is a common angle B, and I have another pair of equal angles. So according to AA similarity criteria, I can say triangle ABD is similar to CBA, and it follows the naming convention also. And hence I can say that the ratio of sides AB by CB equal to BD by BA equal to AD by CA. So corresponding sides of similar triangles, they are in the same ratio. And then I am interested in finding the value of x. So x is actually DC, and DC is not actually part of the similar triangles as such, but I can look at the length BC. BC length will be 4 plus x. So if I look at the ratio of AB by CB equals to BD by BA, I have 8 by 4 plus x. CB length is 4 plus x, that is equal to BD by BA, which is 4 by 8. So if I simplify this further, I get the value of x equal to 12 centimeter. Then moving ahead, the next question is about a map. So there is a survey map of India, and they have mentioned the scale. The scale of the map which is prepared is 2 centimeter to 1 kilometer. So this ratio is like 2 centimeter is the length in the map that corresponds to an actual length of 1 kilometer. So the ratio of length in map is to actual length is 2 centimeter to 1 kilometer. So this is my scale factor given. Now a child finds that the length of the cart track between two settlements is 7.6 centimeter. So this is the length between 2 points in the map. So first they're asking to find the actual length of the cart track on the ground and the actual area of a grid square if each has an area of 4 centimeter square. So if there is a square, a grid square in a map of area 4 centimeter square, that grid in reality is of how much area? This is the question. So then we can answer it like this. First, looking at the scale factor given, 2 centimeter to 1 kilometer is the ratio of length on map by actual length. And if I substitute the values, length on map 1 was given 7.6, and let's say the actual length corresponding to that is x. So if I simplify that further, x will be equal to 1 kilometer by 2 centimeter into 7.6 centimeter. Now before I start doing any conversion, because two lengths are in centimeter, so that will be cancelled. 7.6 by 2 is 3.8. So I have 1 kilometer into 3.8, which comes up to be 3.8 kilometer. So the length on the ground, the actual length, ideally, yes, I have to express in terms of kilometer. So I will write it as 3.8 kilometer. Then if I look at the area of the maps, the ratio of area of map to actual area will be the square of the scale factor. Scale factor was 2 centimeter to 1 kilometer, and the square of that will give me the ratio of areas. And then if I substitute the value, area on the map was 4 centimeters square, and let the actual area, let it be some variable y. So then 2 centimeter whole square is same as 4 centimeters square. 1 kilometer whole square is same as 1 kilometer square. Then 4 centimeters square and 4 centimeters square I can cancel from both the sides. So y value will be just 1 kilometer square. So 1 kilometer square is the actual area of the grid on the ground.